All right, so we are in Algebra 1. Today's date is Monday, March 9th, 2020, 3/9. We're talking about multiplying difference of squares and perfect squares, and those seem kind of like random words until you talk about what they actually mean. So, our objective today is to, Larissa?
Use a shortcut to multiply differences of squares and perfect squares.
All right, so it's all about that shortcut today. Thank you. So first, some vocab. What do I even mean when I'm talking about a difference of squares or perfect squares? Let's start with the first part. So difference of squares. Notice that this a squared is a square. You can label that, and it's kind of silly to label it because it says you literally read that as a squared, so it's obviously a square. And b squared, guess what? That guy is also a square. I know I'm blowing you away with this knowledge. You had no idea that those were squares. And the word difference means subtract. So that is a difference because we are subtracting. And this is your shortcut. If you see these things on the left-hand side, this is the answer. You square the first, subtract, square the last. So our shortcut exists there. Let's talk about some other vocab that we talked about last lesson in 9-3. These things right here are called conjugate pairs. So I'll write that down as well. Is it with a, I think it's with a J, conjugate pairs. So these are both conjugate pairs, and again, the word pair meaning there are two of them, like a pair of socks. My left sock will have a plus sign in between, my right sock will have a minus in between. It doesn't really matter which sock goes where the minus sign and the plus sign goes. I can just switch them and they're still the same thing, but the main thing is they're the same exact numbers. First and first number are the same, second and second number are the same. The only difference is one has a plus, one has a minus. Those are conjugate pairs. Question?
So conjugate is the one with the plus and pairs is the one with the minus? Or just
All together, these two, I call these two things conjugate pairs.
Okay.
That's a good question. So, I will say it one more time. If you see conjugate pairs, one with a plus, one with a minus, then the answer is I square the first, whatever the first number is, then I subtract when I square the last. Okay, so there's our shortcut. We could apply that rule right now, but I want to talk about where it comes from, as we often do in mathematics. So if I'm going to be using my, we're calling this the box method, here's my box, right? I'm going to label the sides of my box, so I'm going to have an A plus B on the top, and I could have put it on the left, and then A minus B on the left. All right, let's get 4 cards in here. First cell, A times A, what goes in here? Who has their card? Yes, what?
A squared.
A squared. Perfect. Thank you. What about in the top right cell? Charles, yes. AB. What about in the bottom left square? Ugo.
Negative B squared.
Ooh, careful. Oh, so, yeah, down in the bottom right. Negative B squared. I agree. And what about in the bottom left? Yeah, Emma? Ooh, careful. So this was A times A. This is now going to be A times B for this square. So it's very similar to this square, but slightly different.
AB squared?
You're really, really close. Just negative AB. Because there's one B, one A, so I just squish them together. And that's kind of the weird thing when you get to polynomial multiplication is if you have a bunch of different things, X, Y, Z, and you multiply them together, you just get X, Y, Z. You smush them together. All right. And then from there, we add up all of the area of the gray square, or the gray rectangle, the box. So I add up the A squared. Are there any like terms? Are there any same letters with the same powers? No. Okay, so that's A squared. What about all my AB terms? I have one there and a negative one there. What's going to happen to those AB terms? How many of them do I have? Kira?
They cancel each other out, so they're gone.
Okay, so they're gone. They do cancel each other out. I have 1, and then I subtract 1, and I'm left with 0. And then finally, I just write down that B squared. And hey, check it out. A squared minus B squared, there is the formula that we had up above. So that's where it comes from. You could go ahead and rederive this. which is a fancy way of saying if you don't know the shortcut from today's lesson, you will be fine. It just takes a little bit more work. Every single time you might have to do this or FOIL, but I do want to show you the shortcut if you want to start doing these faster and faster in your head. All right, so hint, hint, all of these are going to be conjugate pairs, which means we're going to use a shortcut on every single one of these 4 problems. So, first problem. The shortcut tells us I square the first, then I subtract, square the last. Who's got this for us? And who has their card still? A few people have their card. Who wants to give it a shot? Esha?
X squared. I think it'd be minus 4 squared because it's negative 4 plus 4.
I
Wait,
agree.
No,
No, you're right, yeah.
oh.
Negative, and then what is 4 squared? What's 4 times 4?
16.
Done, box it. X squared minus 16.
Wait.
Question, Kira.
So the reason negative 4 and 4 don't cancel each other out is because you're multiplying them?
Yes, so for that last term, exactly. Just like we had down here, that negative 4 and negative and positive 4 come down that bottom right cell and nothing comes out. The 4x and negative 4x will cancel each other out, so there's no x term, there's only an x squared term. But you'll always have the first term and the last term, first and last. Let's try another one. 3 minus y times 3 plus y. Yeah, Ulysses.
So would it be 9 minus y to the power of 2?
It is indeed 9 minus y to the power of 2. Thank you. I also want to point out something that will maybe trick us later, which is this. This is not equal to, so do a giant slash to that equal to sign. This is not equal to 16 minus x squared. These are not the same thing. Whenever you have a minus sign, you have to be very careful in the order in which you write them. So very similarly, this is not equal to y squared minus 9. These are very different things. I mean, you just have to multiply them by -1 and you get the answer, but they're opposites of each other. If you multiply both of these by a -1, then yeah, you get your answer. For example, like 16 times -1, negative 16. And negative x squared times -1, positive x squared. So if I just multiply this by -1, I get this. They're opposites of each other. Questions, Emma?
So if I enter the Academy, I get it wrong.
Exactly. You need to enter the blue, not the orange. Yeah, why?
Could you enter it in Khan Academy by putting a -1 in front of that in parentheses so you distribute the -1?
I've never tried it, but I assume no because I want it as simplified as possible, no extra multiplication in there. So I would guess no, but it's technically correct. Okay, example number 3. Who's got it? You got these nice and fast. Hazi.
Would it be 9 squared?
9x squared.
Minus 25?
It is indeed 9x squared minus 25. Thank you. And I'm going to stop writing the non-equivalencies because I think you guys can probably pick that up. And finally, that hard example, I think, is everyone in now? I think everyone is. All right, go for it. Anyone? Yeah, Emma.
8 squared.
What is 8 squared? You have it? What is 8 squared, though?
Squared.
8 times 8?
64
It is indeed 64. Keep going.
plus 81 squared.
81 squared like that.
Or 81 a squared.
81a squared like that.
Yeah.
Okay. There's a tiny little mistake. I'll see if you can find it. If not, you can hand it off to someone else. But there's a tiny, tiny mistake.
-81 squared.
Yeah, so the sign is always going to be a negative. And I was hoping that someone would make that error, so thank you. The sign will always be a negative in between them. 100% of the time. Question, Esha.
Okay, so can we go up to example 3? And I'm confused on why you put
subtraction between the two numbers because the addition was first.
Ah, yes. So it doesn't matter what order they're in. I can have a plus on the left or a plus on the right. It doesn't matter because if I do positive 5 times negative 5 or negative 5 times positive 5, I'm always going to get negative 25. So that's why we always have the negative 25. The middle term should always cancel out because they're conjugate pairs.
Wait,
Yeah, positive 5 and negative 5 is the same thing as
so it
negative 5
should
times positive
always
5.
be negative. It'll
Always be negative. Yeah, the formula above says always a minus sign. Yeah, and then Jade, and then we'll do here after Jade.
Why do we have a square on the end of 81a squared?
Ah,
We
that's a
already
great question.
multiplied.
Yeah, why is there a square right there? Someone else. Yeah, why?
Is it because the a is a separate number from 81, so you're still squaring the a, but you already squared 9
'Cause it
because
can't
it's a
be a.
constant number and not a variable.
I mean, you
So
could
you
put
can
it
already
as
do
a
that.
Exactly. Yeah. Good explanation. And I do like how you think of it as a different number. Yeah, and then here.
My question was just, is 8 a term and 9a a term, or is the whole thing a term?
8 is a term and 9a is a term. Terms are separated by the minus and plus sign. So there's 2 terms here, 2 terms. So a binomial times a binomial. Good question. Good question. Yeah, keep these questions coming. You guys are getting smarter every time someone asks these questions. All right, so there's our shortcut for a difference of squares. We're going to move into a slightly harder one to memorize, and you'll learn about the metronome that I used to make Riley go to sleep, or at least used to go to sleep. All right, so there are 2 formulas, and they look hard. Look at that. There's letters happening everywhere. Oh my gosh. So let's start off by analyzing. Just ignore all this stuff on the right-hand side. Just this stuff. I have perfect squares. How do I know that? Because it doesn't matter what I have. I can have anything inside this box. As long as that box is squared, I say that is a square. So this a plus b is being squared, so it's a square. This a minus b is being squared, so I'm going to label this. This is a square. Well, if that's a square, look up at our title. We're talking about perfect squares. These are perfect squares because it's exactly a square, and then here's the answer. Well, you can expand it, right? If I do off to the side, you can say, if I have 2 squared, that's equal to 2 times 2. I kind of expand it out. I go from a power into a multiplication. So very similarly, I have a power here, so that means I have 2 of these a plus b's multiplied together, just like I have here. So a plus b times a plus b, I have 2 of these. If I had a plus b to the power of 3, I'd have 3 of these terms. That's all that's saying there. So we expanded it out. And then from there, we get our formula that looks kind of hard to memorize. So there's that guy, and then there's that guy. What are the differences that you see just in terms of the formulas before we go in and derive where these formulas come from? 1 person sees a difference, 2 people see a difference, 3 people see a difference, 4 people. Where's the talk?
Because this, for the next one, they did, instead of writing it twice, they put 2 times a.
Oh yeah, so you're comparing this formula to the last formula? Yeah, so now we have a middle term, right? Is that what you're saying? Okay, yeah. What other differences between the formulas and the formula up above does anyone see? Yeah, Kira.
Well, between like these two, the second one has a subtract symbol.
Yeah, why does this one have a subtract symbol? Is there something over here that you could see that would
Oh.
indicate?
Because a minus b
Oh,
both times.
yeah. So if I have a minus sign in between my square, then my middle term is going to be negative. If I have a plus sign in between my square, all of them are going to be positive or originally positive. Yeah. Other things that people notice about these formulas? I'm sorry, Larissa, I think you kind of figured out right as I gave it to someone else.
Yeah.
Yeah, question, Asha.
So is the a plus b squared along the way? Is that problem being simplified?
I'm expanding it, so I'm talking about how do I multiply these binomials. This is really asking me to multiply binomials in a hidden way. So I'm actually multiplying the binomials for you, which we're going to rederive down here, but it's just expanding it out and saying what times what is equal to the shortcut. This is a shortcut.
Okay.
Charles?
It just distributes the square and then adds it the middle term.
So
Which
you're
is-
really, really
which is-
close. You have to use the correct words for the middle term, though. It's not really adding, it's multiplying.
It's multiplying.
And then doubling.
Yeah.
And that rule in words is almost exactly what I'm going to write down below. Yeah, good insight. Yeah, Kira.
So it seems like doing this you're unsimplifying. Why would you do that?
No, I totally agree with you. Like, it looks so nice right here, and then all of a
Why
sudden it
do
gets
you-
so
yeah.
gross over here.
That's
We're
so-
unsimplifying. You're right. And then I'm going to teach you how to go backwards, which is simplifying. So I'll teach you how to go from something that looks like that into something that looks nice and concise like that. So I don't disagree with you. But I do want to show you how do I multiply these terms, and it does get a little bit gross, and it gets a little bit hairy. And as a general rule of thumb, the more and more multiplications I do, like in Algebra 2, I'm going to teach you what happens when I do this to the power of 7. It gets really, really gross really, really fast. So just be careful. Yeah, Wyatt?
What does it look like in the box form? How do you like put it in the box?
That's a perfect segue. How do we put it in the box? Let's do this. So, where does the formula come from? Let's do the positive one, a plus b. So this is going to be a plus b times a plus b. I'm multiplying two of those a plus b's together. All right, so we're going to go rapid fire now because everyone is in. First, top left cell is Charles.
A squared.
A squared. Top right cell is Wyatt.
AB.
AB. Bottom left cell is Ugo.
AB.
AB. Bottom right cell is Ulysses.
B squared.
B squared. Perfect. And take a note, if I add all the like terms, these diagonals typically are going to be the like terms, and they are in this case because I have the same letter to the same power, a to the 1, and I have b to the 1, so those are like terms. And I say, well, how many of these, if I think of them as, I always think of them as fruit for some reason. I think of that as an apple. They're like terms. I can say I have one apple and another apple. I have two of those apples. I have two of those AB terms. So I write this down. I have an a squared term. I have two of those AB terms, and finally I have a b squared term. So there's the derivation of the first formula. Charles, question.
Do you always have to write it in that fashion, or could you do like a plus? Oh wait, never mind.
So
That would just be writing that.
no, you could definitely rewrite this as a squared plus b squared plus 2ab, or 2ab plus a squared plus b squared. There's a bunch of different ways that you can write it, and they're technically all in standard form, which again, I forgot to talk about. That's in 9-0, so that's my bad. Kira.
Actually, well, so the reason this one you're getting a different answer from above, like the equations we did above, is because there's a plus and there's the same symbol in both like groups, and that's why you got the 2ab instead of like the way it is above.
So I'm looking this compared to this, right?
No. It's like you got the a squared plus 2ab plus b squared, and that's like the answer of a plus b plus times a plus b.
Right.
And so you got that answer because it's plus in both groups.
Yep. Exactly. And then we're going to do one where it's minus in between each of them, so I have space to do that. So let's do that really quickly. On the right-hand side, I have a minus b and a minus b. Again, we're going to kind of rapid fire go through this. Top left, Charles. A squared. Top right, Ugo.
Negative AB.
Negative AB. Bottom left, Ulysses.
Negative AB.
Negative AB again, nice. And then finally, bottom right, be careful here, Emma.
B squared.
It is indeed a positive b squared. And then I add all these together. I have a -1 and a -1 for the ab's. Those are still my like terms, so I have an a squared minus 2ab plus b squared. And you see that it matches up with our formula up above. Again, I'll say it once again. If you don't know these shortcuts, just use your general rectangle and or your box method. It will work. This is just me trying to show you a faster way of doing it. All right, so this is the nursery rhyme, the famous nursery rhyme. For about a year of trying to put Riley to sleep, this is the thing that worked. So
What?
imagine you guys are all going to do this with me. You're holding a baby, and this is perfect for Jade. If you need him to go to sleep, right? So if you have a baby in your arms, everyone hold your baby. Are you holding his head? Are you supporting his head? Okay. So you're holding your baby. You're going to square the first, double the product, square the last. Oh man, if you do that too many times, you're going to fall asleep. Square the first, double the product, square the last. Everyone with me, ready? Square the first, double the product, square the last. Again, Square the first, double the product, square the last.
That's what I'm gonna be doing.
You are going to put any baby to sleep now. You have the power. I have given it to you. Can you handle this power? So we're going to write it down again. We're going to square the first, double the product, and square the last. I really should have taken a video of me doing this because I totally legit did this and it did put him to sleep. It took me maybe, I don't know, 15 incantations of this, but it does put babies to sleep. Square the first, double the product, square the last. And I will be referring to this rule for the rest of your high school career. I still talk to my AP calculus class. They're like, oh shoot, I see a square, what do I do? I'm like, oh yeah, square the first, double the product, square the last. So there's our rule, and this is, I'm going to call it Charles' rule because he basically said the same thing at the very beginning, which is, hey, that first term is squared. Oh, I multiply those two, a product, and then I double that product, so double the product, and then I finally square the last. So that's exactly, I mean, this in words is that down there, like verbatim. All right, so let's try it out. So every single time you're doing this, you don't have to physically do this action, but you need to mentally be doing it. You're like, okay, first I'm going to, square the first, then double the product, and then square the last. All right, so this x plus 5 squared. Do the first one. Who's got it? Kira.
So first I think you should make it into two equations. So x plus 5 times x plus 5.
So you could, I'm going to try to only use the shortcut here. So you're doing kind of the longer expansion, which is totally fine, but I'm going to try to limit us to just doing the shortcut. So just use our rocking our baby to sleep. So I want you to square the first right now.
So x squared.
Perfect.
And then
That middle step is kind of hard.
10
Yep. 10.
plus 10.
Ooh, careful here. So the product of 5 times x
10x.
is 10x. Yeah, so not squared. So let me just make sure that we're all on the same page. So 5 times x is 5x. So we say the product of 5 and x is 5x. Then double 5x. 10x gives us 10x. So that's doubling the product.
Oh, I see. The product of those two.
Yes. I'll say that once again. 5 times x is 5x. Doubling 5x, 2 of those 5x's is 10x. And I'm going to write that down underneath as well. So the product, I'm going to write P for product. The product is 5x. And then we had to double that. So we had to do times 2 in order to get to that middle term. And then finally, Kira.
And then you square the last, which is, I don't know what the last number is.
There's the last number.
Oh, 5 squared.
Which is?
Oh, 25.
Done. And box it. Yeah, doubling that product is the hardest piece of this, but once you have it, then you're ready to go. Again, please go faster than me. The Khan Academy assignment is already up, so thank you to those of you that already are doing that. Square the first, double the product, square the last. Who's got the next one? Yes, Charles.
It would be, 47 minus 14c plus c squared.
What was it? I didn't hear the last part.
C squared.
Plus c squared. There's a tiny little mistake, and I'll see if you can find it. It's not a big mistake. It's one of those I messed up with a silly mistake. And if not, you can give it to someone else.
Oh, 49.
Ah, there it is, yeah. So, come back here, grab you, 49.
There we go.
I have a question.
Yes, go for it, Desha.
So why did he not square 7? Why did he not do 7 squared?
Oh, he did, yeah. So 7 squared is 49. So instead of writing 7 squared out, we just squared it and we said it's 49.
Okay, so he did 7 squared and then he combined the terms and he doubled it and got 14c.
Yeah, so the product was negative 7c, right? Negative c times 7 is negative 7c. And then he doubled it to get negative 14c.
Okay. And then he just squared the last thing.
Yep.
And
Oh, keep going, Esha. We'll come back to you, Emma.
how is the last thing an addition sign before this is?
I was hoping someone would ask. That is a perfect question. Someone else answer it. Charles.
Because it's negative times negative.
Oh. Oh, yeah.
Isn't that interesting? Yeah.
Okay.
Which means it will always be a plus sign, which is cool, right? Because, I mean, it does match our formula, which is like, okay, well, Mr. Snell, you know the formula, but it means something. That's always a plus sign, and both of them, even though I have a minus sign, because a negative times a negative is a positive. Yeah, great insight, guys. All right, other questions? It goes to Emma, and then we'll go to Kira.
So then why did you have C squared up
Yeah, so can someone else answer that? Why did we have this c squared at the end? Where did that come from? Asha?
Because in the steps, the last one is square the last, and C is the last letter or variable, last thing in the problem.
Yeah, they're called terms, so
Terms.
last term, yeah.
Last term.
Yeah. Does that answer?
Yeah.
Cool, and then Kira.
What I'm confused about is why did you get negative 7c? Because you're doing 7 minus c, not 7 times negative c.
You're right, yeah, so the exact expression is 7 minus c, but if I'm talking about the product of the first and the last, the product, to get this middle term, is 7 times negative c. That is the definition of a product, just multiply. So I agree that you should be subtracting these, but in our shortcut, we're trying to multiply these two together. All right, let's move on to example number 7. Yes, Wyatt.
Would it be 4y squared plus 4y plus 1?
It is indeed. Let's check his steps again. We square the first. 2y squared. Well, y squared is y squared. 2 squared is 4, so that is squaring the first. Now let's check his product. The product of 2y and 1, oh, that's easy to do. So 2y times 1, that's the product, right? Oh, I don't know why I wrote 2 there. My brain and hand are disconnected. Yeah, the product is 2y times 1. We multiply these two together, and then secondly 2y times positive 1. So yeah, the product is just 2y, and we double the 2y to get 4y. Okay, we square the first, we double the product, and then finally, we're going to square the last. Well, 1 squared, that's a really easy problem. That's 1, and we're done. Yeah, good job, Wyatt. All right, and then example number 8. Our final example of today's notes. Kira?
Well, I think you can just pretend, like if you want to keep doing it the same way, you could just pretend the second equation isn't there and put a squared on the first one.
Yeah.
And then you'd get 36, and then 6 times 4 is 24, but it'd be negative 24.
Yep, so the product you're saying is...
24x squared, though.
Ooh, careful. So if I'm just multiplying these two, there's only one of those x's, so I should just have one of those
right.
x's.
Yeah.
Negative 24x, and then plus 16.
Oh, so careful. What is the middle
36
term?
Minus 24x, plus 16x squared.
You're really, really close. There's a tiny mistake. And it's one of the mistakes from the process that we just learned.
I don't know.
You can call on someone. There's a few hands up.
Charles.
Wouldn't you, like, solve the equation in parentheses?
That's not quite it.
That was for 24 to get 24. Oh, yeah.
Double the product. What's negative 24 times 2?
Oh. Well, that's a big number.
Double each term. What's double 2, double 4?
48.
There it is. Yeah, we multiply by 2 to get that negative 48x. And there's our final answer. Box it.
Okay, so you multiply the numbers inside.
Yes, so in order to get that middle term, you always multiply the 6 by the negative 4x, you get the negative 24x, and then multiply by 2. That's the doubling the product, that second swing. And if you want to think about the other rule, it's kind of like, I don't want you to be thinking about shaking your baby, but it's like, you know how we do square the first, double the product, square the last? It's like square the first, square the last. You like kind of miss that middle swing. So there are your quick examples.
Just to kill your baby sweater.
Yeah, don't do that. Be careful. Can you guys give me a fist of 5 for today's notes? And our objective again was, can you use the shortcut to multiply difference of squares and perfect squares. I'm seeing a question, so 4, 5, 5, 4, 4, 4, 5, 4, 5, and 5. All right. Yes, question, Charles.
Are we doing the second equation on the homework, or?
So there's 2 homework assignments, I hope.
There is?
Did I not assign one of them?
No, you didn't assign the this.
Okay, that's my bad.
Yeah.
I'll go do that now.